Okay, the last section for this chapter, 6.5, and we're going to solve quadratic problems using function models. So this whole section now will tie everything together, and we'll concentrate on solving story problems. You have to remember that three forms of the equations that we looked at are quadratic equations. Those have been standard form. We have ax squared plus bx plus c. We have factored form, where r and s are roots or x-intercepts. And we have the vertex form, where we have the vertex, p and q, and all these we have the value of a. So, first question now, applying quadratic models in problem solving. So, quarterback throws a ball from initial height of 6 feet. Is caught by the receiver 50 feet away at a height of 6 feet. The ball reaches a maximum height of 20 feet during its flight. Determine the quadratic function which models this situation and state the domain and range. So here, going down the side, we have a series of steps. First, we're going to sketch a picture. So a quarterback throws a ball from initial height of 6 feet. So we know that the ball is going to start at a height of 6 feet here. So on the y-intercept, we should have height. And this is our distance. And so the ball is going to get thrown up. It's going to go across. And then it's going to get caught by the receiver, also at a height of 6 feet. So your receiver is over here, and the quarterback is over here, throwing the ball. Now the maximum height, we're told, is 20 feet. So if you went back here, should be at a height of 20. And this was caught 50 feet away. Now, based on the information given in the problem, sketch the best form for modeling the problem. If the vertex is given, select the vertex form. If the x-intercepts are given, select the factored form. But since the ball didn't hit the ground, we don't have the x-intercepts, so we don't have this form. We would know the vertex. Starts at 6 feet, and this is the important part, is caught at 6 feet. So the height's the same, so the path is symmetric. So then the axis of symmetry should occur at 25 feet. So the vertex, when the ball has traveled 25 feet across, it's reached a height of 20 feet. So we have the vertex form. So x minus p squared plus q. Alright, now that we select the correct form, let's fill in the values that we have. So x subtract, and we put in the x value of the vertex squared plus the y value of the vertex. Now, substitute the information given into quadratic form that was selected and determine the value of a. So we now need to find the value of a. So we have to put in value for x and y. Now we have two values we could put in. You know this value here, 0.6, where it's 0 meters away from the person. The ball started at 6 feet high. And when the ball was 50 feet away, it was at a height of 6. So we can put either in, does not matter. I'm going to put in 0.6. So I'm going to sub that in. And the reason being because I have x value of 0, which should make the calculations a little bit easier. So the y value is 6. 0 subtract 25 squared plus 20. 6 equals a. Now negative 0 subtract 25 is negative 25 squared, which should be 625 plus 20. Now to solve, we bring the 20 over to the other side. 6 subtract 20. A times 625. Or you could write 625a, doesn't matter. So negative 14 equals 625 times a. Now find the value of a. We need to get rid of 625. So we divide both sides by 625. A equals, that's going to be a negative value. 14 divided by 625. 2, 2, 4. So our complete equation is y equals negative 0.0224 times x minus 25 squared plus 20. If we just look back to our question, we would expect the value of a to be negative. Since the graph is pointing down here, alright, and that question's done. If I would just want to continue just further for a second, if I was asked state the domain, all x values, and my x values are between 0 and 50. So between 0 and 50, this is my domain. And the range, I reach maximum height of 20, and the lowest height, or value of the height could be, is 6. So the range, y values, since the ball starts at a height of 6 and is caught at a height of 6, and it never reaches height any higher than 20.